Looking at the spectrogram, we can tell where different sounds are based on different acoustic characteristics. So we can tell this is the S sound here because of the lack of a voice bar. It's a voiceless sound, which means we won't see a voice bar. Our vocal folds are abducted during the production of that sound, which means we won't have a voice bar here. As well, S is a fricative, so during the production of S, there's a lot of turbulence created during the production of S, turbulence within the air, and frication, which is why we have this spotty distribution here. As well as in the production of S, we bring our tongue to our alveolar ridge in the production, and that air gets pushed through. That's the turbulence there in the spotty distribution. But while doing that with our articulators, we kind of make our oral cavity a bit smaller, leading to the amplification of these higher frequencies here, which is why it's a bit darker up top in the higher frequencies, showing that amplification. Then looking at our vowel sounds, so the A, the I, and then the two vowels, and again, we can identify these vowels because we see these glottal pulse lines at the bottom, these clear vertical lines at the bottom, the very bottom, where the voice bar is, because vowels are all voice sounds. As well as we see these clear formant bars, and the voice bar kind of blends into the first formant here. But we see this with all of these vowels. We see the formant bars here and here and here as well, because when we produce vowels, our vocal folds are adducted, which is why we see that voice bar at the bottom of each vowel sound. But then with the production of that sound, our vocal tract is pretty unobstructed. So it allows for really great resonance and harmonics as that air travels through our vocal tract. So that's why we see these dark bars here where multiple frequencies are going to be amplified. So moving on to the B sound, we see a voice bar here because B is a voiced stop, meaning our vocal folds are going to be adducted, so you see a voice bar. As well as we see a stop gap here where there aren't really any frequencies that are going to be amplified, because this is when we are building up air behind a constriction for the production of that stop. So we aren't doing anything, we're just building up air in order to give that puff of air out in the production of it. So we are building up air here, and then you see a dark line here with some aperiodic energy. This is our stop burst where we release that air. So we build up the air behind the constriction, we produce a B at the point of our lips, and we let the air go through our lips in that stop burst. Then with the production of a T sound, a T is also a stop, so we see that stop gap where the air is built up behind a constriction. We produce a T sound with our tongue at our alveolar ridge. We let the air go, and we see again that aperiodic energy with that stop burst, that dark line there, when we let that quick burst of air go. However, we don't see a voice bar at the bottom because T is a voiceless sound, which means our vocal folds are abducted in the production of that sound. With the G sound, again, another stop, a voice stop, so our vocal folds are adducted, so we see the voice bar. The stop gap, because we're building up that air pressure. G is produced at the point of the velum. Then we let that, we release that air in a quick burst of energy, which is this dark line here, which is the aperiodic energy, quick burst of energy, called a stop burst with that dark line there. Then we can tell this is the N sound here because N's tend to look a lot like a vowel sound. When we're looking at them on a spectrogram, we have a voice bar at the bottom because it is a voiced sound, so our vocal folds are adducted in the production of that sound. But they tend to kind of have these sort of muted formant bars, because when we produce an N sound, our vocal tract is sort of still fairly open, but the air continues to travel up and through our nasal cavity, and because it continues to travel through there and that extra tissue that's in the nasal cavity, a lot of that tissue absorbs some extra sound energy as it travels through, which is why we see that these bars here are going to be a little bit lighter in color in comparison to the formant bars for the previous vowel, because of that that sound energy being
absorbed.